Let's explore how to calculate the average, also known as the mean, of a set of numbers. The average gives us a single value that represents the central tendency of our data. Here we have five numbers: 4, 7, 10, 13, and 16. We can use these values to demonstrate how the average formula works. The average will give us the typical value in this dataset. The first step in finding the average is to add all our numbers together. This will give us the total sum of our dataset. So we have 4 plus 7 plus 10 plus 13 plus 16. If we calculate this sum, we get 50. This represents the total of all our values combined. But the average isn't just the sum. We need one more step. For the second step, we need to divide this sum by the count of numbers in our dataset. This division is what gives us the average or mean value. It helps distribute the total value evenly across all items. In our example, we divide the sum 50 by 5, since we have 5 numbers in our dataset. The result is 10, which means the average of our 5 numbers is 10. This average tells us that if all numbers in our set had the same value, that value would be 10. Now let's express this calculation as a general formula that works for any set of numbers. The general formula states that the average equals the sum of all values divided by the number of values. The numerator in blue represents all our values added together, while the denominator in green represents the count of values we have. This formula is universal and applies to any set of numbers, not just our example. If you have test scores, heights, temperatures, or any other numerical data, you can use this same formula to find the average. It doesn't matter how many values you have or what the values are. Understanding the average is important because it helps us summarize data with a single value. It tells us about the central tendency of our dataset, which is often more useful than looking at each individual value separately. Let's explore the concept of average with a concrete example using 5 numbers: 4, 6, 8, 10, and 12. The average, also called the mean, gives us a central value that represents our entire dataset. To calculate the average, we follow 2 steps. First, we add all the numbers together to find their total sum. Adding num to our running total gives us running sum. We've now added all 5 numbers, 4, 6, 8, 10, and 12, giving us a total sum of 40. For the second step of finding the average, we divide this sum by the number of values in our set. Since we have 5 numbers, we divide 40 by 5. This calculation gives us 8 as the average. Think of the average as distributing the total value equally among all the items in our set. If each of our 5 numbers had the same value, that value would be 8. To better understand what this average represents, let's visualize our numbers on a number line and see how they relate to this average value of 8. Here's our number line with values from 0 to 16. Let's mark the average value of 8 on this line. Now, let's place our original 5 numbers on the number line to see how they're distributed around the average. An interesting property of the average is how each value relates to it. Let's measure the distance of each number from our average of 8. The number num is num minus 8, away from our average. Since it's below if num 8, else above if num 8, else exactly at the average, we can represent this as distance text. Looking at these distances, we can see a fascinating pattern. The values below the average are 4 and 6, which are 4 and 2 units below 8, giving us distances of -4 and -2. The values above the average are 10 and 12, which are 2 and 4 units above 8, giving us distances of +2 and +4. And our middle value, 8, is exactly at the average with 0 distance. This isn't a coincidence. If we add all these distances together, -4, -2, 0, +2, and +4, they sum to 0. This is a fundamental property of the average. It acts as a perfect balance point where all deviations cancel out. To illustrate this balancing property, let's imagine our number line as a seesaw with the average as the fulcrum or balance point. The average value creates perfect balance because the total distance of values below the average exactly equals the total distance of values above the average. In our example, -4 plus -2 equals -6, which is balanced by +2 plus +4 equaling +6. This balance equation shows that when we add all the deviations from the average, we always get 0. This is why the average is so useful. It represents a central point that minimizes the overall distance to all values in our dataset. Let's explore how data points balance around the mean value, an important concept that helps us understand why the average formula works the way it does. Here we have a number line from 0 to 16. Let's consider a small dataset with 5 values, 4, 6, 8, 10, and 12. We'll place these points on our number line to visualize how they're distributed. The point 8, highlighted in red, is the mean of our dataset. To verify this, we can calculate the mean by adding all values and dividing by the number of data points. 4 plus 6 plus 8 plus 10 plus 12 equals 40, and 40 divided by 5 equals 8. Let's add vertical lines to help visualize each data point's position on our number line. These lines will make it easier to see how each value relates to the mean. Now let's measure how far each data point is from the mean. This distance is found by subtracting the mean from each value. If the result is negative, the point is below the mean. If it's positive, the point is above the mean. Looking at these values, we can see that 4 is 4 units below the mean, giving us -4. Similarly, 6 is 2 units below the mean, giving us -2. The point 8 is exactly at the mean, so its distance is 0. The point 10 is 2 units above the mean, giving us +2, and 12 is 4 units above, giving us +4. These arrows help us visualize how each point relates to the mean. Now, let's think about the mean as a balancing point, like a fulcrum on a seesaw. This will help us understand a key property of averages. Imagine this triangle as the fulcrum of a balance scale, with the mean at position 8 serving as our balancing point. In physics, the distance from the fulcrum affects how much each weight influences the balance. Let's analyze the balance of our data points. The point at 4 is 4 units to the left of our fulcrum, creating a -4 force. The point at 12 is 4 units to the right, creating a +4 force. Similarly, 6 is 2 units to the left with -2 force, and 10 is 2 units to the right with +2 force. What's fascinating is that our data perfectly balances around the mean. The negative forces on the left side exactly cancel out the positive forces on the right side. This isn't a coincidence. It's a fundamental property of the arithmetic mean. We can write this mathematically. Each data point minus the mean creates a distance. When we add all these distances together, we get 4 minus 8 plus 6 minus 8 plus 8 minus 8 plus 10 minus 8 plus 12 minus 8 equals 0. Simplifying this equation, -4 plus -2 plus 0 plus 2 plus 4 equals 0. The negative and positive values perfectly cancel each other out. This is why the sum of deviations from the mean always equals 0. This balancing property is what makes the mean so useful in statistics. It's the only point where the sum of all deviations equals 0. In other words, the mean is the exact balancing point of all values in our dataset. To summarize, the mean is the balancing point of a dataset. Mathematically, we write this as the sum of x sub I minus x bar equals 0. This means that the sum of all deviations from the mean always equals 0, which is what creates the perfect balance we observed. Let's recap what we've learned about averages. This simple but powerful formula shows us that the average is calculated by taking the sum of all values and dividing by the number of values in our dataset. We can write this formula in a more compact way. Average equals sum divided by count. This simple equation is the foundation of how we find the central value in any collection of numbers. Let's look at what an average actually does. Here we have 5 different values: 3, 7, 12, 5, and 9. The average takes all these diverse data points and combines them into a single representative value. The average acts as a central value, a single number that best represents the entire dataset. Think of it as the spokesperson for all your data points, telling you where the middle of your data lies. On a number line, we can visualize our data differently. The average, which for our 5 numbers is 7.2, sits at the balance point. If our data points were weights on this line, the average would be where the line perfectly balances. Let's explore some important properties of the average that help us understand why it's so useful in mathematics and data analysis. First, the average represents the center of our data, giving us a focal point around which all values are distributed. This helps us understand where most of our data tends to cluster. Second, the average balances the values that are above it with those that are below it. The sum of distances from data points above the average equals the sum of distances from points below it. Third, the average is an essential tool in data analysis across many fields, from science and economics to sports and weather forecasting. It gives us a quick way to make sense of large amounts of information. Now let's return to our formula. This simple equation, average equals sum divided by count, connects all the concepts we've discussed. The average formula truly is the heart of every data set. It distills complex information into a single, meaningful number that helps us understand patterns and make decisions. Mastering the average formula gives you a powerful tool for interpreting data effectively. Whether you're analyzing test scores, temperatures, or prices, understanding averages helps you see the bigger picture. The average formula, sum divided by count, transforms a collection of numbers into a single representative value that helps us understand our data more clearly and make better decisions based on it.